everyone. Thank you for being here. My project proposes a new framework treating psychology as a biological light system. The model that I'm presenting today links photon absorption, proton chemistry, and neural excitability to explain how exactly psychological states are established or emerge from physical processes. These physical processes exist within the self and the environment. So, in other words, what goes in must come out. It's a circulation system. So, my core idea is that psychological quote unquote phenomena are not abstract or immaterial. They arise from quantifiable biophysical events. Light matter interactions initiate electron and proton dynamics that shape perception, attention, affect, and behavior. To name a few, these are the main four pillars, but we can get into just about everything from cognition and on. So, this hypothesis, my photon squared threshold hypothesis, states when the area irradiance term reaches a photon squared threshold, photonic input becomes biologically relevant for psychological processes. This hypothesis is the backbone to the research in question. So the next few slides are going to discuss more of this, and I hope you enjoy, and I'll be back. Talk to you soon. So in the first stage, beta is just a fitted scaling constant. Okay, we compute it from the relationship between area, which is A, the irradiance, which is E, and then the point where you can see the reliable change, or in other words, the observed threshold, which is going to be represented as P. Okay, we're using this equation because it's simple, it's falsifiable, it's experimentally measurable, and so forth. Now, beta in the first stage is purely a mathematical scaling parameter you estimate from the data. And then only after we have a stable empirical beta, which then you can calculate by wavelength and then by psychological state, do we have something that we can try to decompose into an anatomical beta. Okay, the anatomical beta linked to the adrenergic tone, excuse me. There's several betas in the body. The adrenergic tone is likely the most reliable. So we're not going to assume it yet. Okay, we're going to link it to the adrenergic tone, pupil metrics, and LC activity. Then what beta is biologically, we can let the data define it first and then map it into or onto autonomy. Okay, so let me walk you through the mechanistic chain that anchors this entire framework. Okay, the point of this slide is to show that I'm not proposing a speculative or a metaphorical model. Okay, each step is grounded in established biophysics. So we start with the photon absorption. When a photon interacts with a chromophore, whether that's retinol classical phototransduction or cytochrome C oxidase in mitochondria, it excites an electron. Okay. The electron level event is the physical trigger that initiates downstream biochemical cascades. This is well characterized in both visual physiology and also in literature on photobiomodulation. Okay. Now, once electrons shift energetic states, they alter proton and ion flux. That produces localized pH microdomains, which are not random. They're actually regulated, they're measurable, and they're known to modulate membrane excitability. Proton sensitive channels, for example, the ASICs, convert those pH shifts directly into ionic currents. So those ionic currents change the probability that a neuron fires. And once you alter firing probability, you alter the network level level patterns that determine whether a stimulus is detected, if it's ignored, or if it's consciously reported. Okay, so this chain, the photon to electron to proton to excitability to behavior, okay, it's basically a biophysical pathway linking light matter interactions to psychological outcomes. Now, I want to just quickly re-emphasize the importance of nitrogen and homeostasis in the experimental process alone, because nitrogen specifically due to the need for a constraint. So nitrogen variables and their constants need to be recognized within the experiment to act as a constraint. Homeostasis as well. These types of metabolisms are essential because they're the pathways that influence and mask photonic neural effects. The molecular wave formation. This is also important within the testing process because the retinal molecular waves create the conversions from photons into excitations that ultimately activate mitochondrial and protonic cellular responses. So to summarize the 4 stages of testing, it's going to begin with the spectral mapping, which will reveal the wavelength-dependent non-thermal neural interactions, which then are going to be guiding the anatomical collaboration we discussed earlier for specifically neuromodulatory measurements. Okay, I'd just like to conclude this presentation reiterating how this framework makes psychology experimentally tractable. It does this by bridging molecular, cellular, circuit, and behavioral levels, and also by integrating psychosocial state with biophysical sensitivity. It offers a new way to understand perception, affect, and social bonding as emergent outcomes of light-driven, proton-modulated biological systems. By addressing the current absence of a physically grounded mechanistic chain in psychology, this model provides the missing link between biophysics and behavior. Now, again, the proton microdomains are well documented, but they remain absent from any previous psychological theory. So ultimately, my work reframes psychology as a quantitative, multi-scale science grounded in physical law. Thank you so much for your time, and I hope you enjoyed my presentation.